This video will focus on circuit basics. We will be figuring out some of the basics of electrical circuits, and we will be spending a little bit of time reviewing some of the academic language that is associated with circuitry. So we have electric charges all around us. Electrons, which we use the negative symbol to represent, and protons, which we use the positive symbol to represent, are usually balanced out. So we just never notice that they're even around. However, when there is a separation between electrons and protons, then the charges really start to flow. Lightning during a thunderstorm is an excellent example of this. The lower portion of a thunderstorm cloud becomes negatively charged, and the upper portion becomes positively charged. This difference in charges sets up an electric field, and those charges seek to regain balance again. So, lightning is simply the flow of electricity from the negatively charged area on the bottom of the thunderstorm cloud towards the positively charged area on the top of the thunderstorm cloud. And that flow serves to balance the charges out within that cloud. So the battery in an electrical circuit provides the charge separation that's needed to create a flow of charge. So here's how that works. So here's a battery right here. Most batteries have an anode end, which is negative, and a cathode end, which is positive. So electrons over here at the anode end actually collect when a chemical reaction occurs inside the battery. So this sets up this really nice charge separation between that anode and the cathode. So normally the charges would balance out by flowing like lightning. So the electrons would flow towards the cathode side. However, the battery is actually designed so that there isn't a path for those charges to flow through the battery. So it turns out that charges can only flow when the battery is actually added to a circuit, which is what we're seeing here, that connects the anode, so the negative end of the battery, to the positive end of the battery, the cathode. And we use materials in that circuit through which charge can flow. So that would be conductive materials, so things like copper. If we go ahead and place a light bulb in, or an LED light in the path of that electric current, you can actually use some of that current's energy to light up the light bulb like we see right here.